Hello everybody, how you doing? This is Mr. Dowse. Today's lesson is going to be about arc length of a circle. What is arc length? It's part of a circle defined by 2 points. Let's say I had circle A, and I had 2 points on the circle, points B and point C. What if I want to find the distance between those points? Well, that's what we mean by arc length. And so whenever we want to find part of the distance around a circle, we refer to it as arc length. I often think of this as pizza. Let's say I had a slice of pizza and went from A to B and A to C, and I was just trying to measure the distance of the crust. Well, then that's another version or another way of looking at arc length, like the distance or the length of a piece of crust on a pizza. So there's two kinds of arc length. One is measuring by degrees, the other one is measuring by distance. When I say by distance, I mean like inches, feet, centimeters, something you can measure with a ruler. Now the degree one is very easy to do. If you know what the central angle is, when I say central angle, the vertex of the angle is actually the center of the circle. So this is a central angle because the vertex of the angles actually hitting the center of the circle. If you know what the central angle is, then you can find the arc length. And we say the measure of arc BC, this is from B to C, this is arc BC, it's going to equal whatever the central angle is. So I can say, since the central angle is 75 degrees, then I can say the measure of arc BC is 75 degrees. Whenever you're talking about degrees, you're going to say the measure of. You don't really refer to it as arc length, but I kind of do. And we're going to call this the measure of arc BC as 75 degrees. This isn't very practical, though. You're not going to hear anybody talking about going 75 degrees around a circle. You're going to hear people talking about going 6 inches around a circle, maybe going, I don't know, 14 feet or 3 centimeters around the circle. It's much easier. People can relate to inches, feet, and centimeters more than they can to degrees. And so the way to define the distance or the arc length from B to C in this case is you need to know a central angle and you need to know the radius of the circle. If you can find, or if you know both of these values, then you can set it up in a proportion, cross multiply, and you can find the arc length in this case. And so let me explain this proportion. This proportion is comparing the central angle over 360 degrees, setting it equal to the arc length over 2 pi r. Now 2 pi r is actually the circumference. So this is the part of the distance around a circle over the whole distance around the circle. This is part of the angle measure around a circle over the entire angle measure around a circle. So we're comparing part over whole equals part over whole. Now we know that a circle is 360 degrees going around it. We know we can find the distance around a circle if we have the radius. And then if we can find the central angle, cross multiply, find arc length, and it's actually pretty easy to do. And I have 3 examples that I'm going to show you here. The first one is finding the arc length. What if I want to find the arc length here? So let's say find arc length of BC. I'm going to call this guy the unknown variable. I'm going to put an X here for the unknown variable. Now I'm going to set up a proportion using this proportion that I have set up here. Do I know what the central angle is? Yes, it is 75 degrees. Do I know 360 degrees? Yeah, that's pretty easy. So I'm already halfway done with the proportion already. Now the arc length is what I'm finding. I'm going to put an X here. We know what 2 is. Pi, I'm going to use 3.14. And then the radius I know is 10 inches. And so I'm actually going to, that's a little messy there. I'm actually going to simplify this guy before I start to do any cross multiplying. So I'm going to plug this in my calculator very quickly here. So 2 times 3.14 times 10, that gets me 62.8. So I'm going to simplify this down to 62.8 inches. I'm going to leave everything else as is, 75 degrees over 360 degrees. Now when I cross multiply here, I'm going to do 75 times 62.8, and I get 4,710. That's going to be equal to 360 times x, which is just 360x. Sorry for the sloppy handwriting here. And then my way to find the arc length is just divide by 360, which hopefully you guys are familiar how to do proportion and cross multiplying. And when I do that, what is 4,710 divided by 360? I get 13.1. I'm going to round this to the nearest tenth. This is 13.1 inches. Sorry, the inches should have carried over. And that is going to be x. And that is the length of the arc. So this arc length is now 13.1 inches. And that's it. So the trick here was I knew the central angle, I knew the radius, so I can just simplify, cross multiply, and then bada boom, bada bing, I'm done. Now the next kind of problem I'm going to do is what if you're trying to find the central angle? This is how they're going to kind of throw a monkey wrench into these problems to try to make it more tricky. So this problem here says find the central angle to the nearest degree if arc DF has an arc length of 9 centimeters. So I'm going to say the arc length here, this guy right here, is 9 centimeters. We know the radius is 4 inches according to the picture. We're finding the central angle, and so the central angle is going to be x here over 360 degrees equals arc length we know is 9 centimeters over 2 times 3.14 times the radius is 4 centimeters. And so let's simplify. Again, I'm going to simplify this guy first before I do anything. 2 times 3.14 times 4 centimeters. And I get 25.12. Let's say we have 9 centimeters on top. X is on top over 360. Now I'm just going to cross multiply these. What is x times 25.12? Well, 25.12x equals, what's 9 times 360? 9 times 360 is 3,240. Now, just divide everything by 25.12. And x is equal to, I get roughly 128.98. I'm going to make that 129 degrees. So I'm just rounding this to the nearest whole number, the nearest whole degree basically, which is 129 degrees. And I now know the central angle was 129 degrees. Pretty straightforward, I hope. The very last example might be the more challenging one, and that is going to be how do you find the radius? So find the radius of circle G if the arc of HJG, ooh, that should be K. It's a typo, sorry about that. That should be a K, my bad. Apparently I can't fix it very easily here. So anyways, find the radius of circle G if the arc of HJK has an arc length of 27.5 feet. So anyways, what we have here, we're trying to find the radius. So let's say we don't know what the radius is. Well, we do know the central angle, so that's 225 degrees over 360 degrees equals arc length. We know this, that's the length from H to J to K. They told us is 27.5 feet. And then we know what 2 is, we know what pi is, but we don't know the radius. Again, what I would do here is I would simplify what we know here. So we're going to have 225 over 360 equals 27.5 feet over, this becomes 6.28 times the radius. Now what we're going to do here is we're going to multiply these two together, but we've got to leave that r. So I'm going to do 225 times 6.28. And I get 1,413 r, because we're multiplying numbers, but r's kind of go along for the ride, equals 360 times 27.5, and I get roughly 9,900. Now, if I divide by 1413, the radius ends up being, I get 7. 7.00 is basically 7. This is 7 feet. Can't forget the units here. So I found the radius to be 7 feet. Anyways, I talked to you about arc length, and I showed you how to find arc length I showed you how to use the proportion for arc length 3 different ways. Hopefully this helps you out, and have a good day. Bye-bye.